Welcome back, fellow audiophiles. This is OCA, your obsessive compulsive audiophile, and this is part 2 of our deep dive into home theater optimization by Nexus. Now on to setting up REW. I reset the REW's preferences, so it's gonna start from scratch so you can see everything I change. At the moment, I connected the Audyssey microphone, UMic microphone, and my analog XLR Earthworks microphone through an audio interface, all three. And as you see with REW, it automatically detects the UMic microphones and already asking for a calibration file, which I have. You have to go to your PC and find where it is. Not easy, but I have calibration files here. Okay, I have two calibration files. This is for horizontal position microphone. This is for vertical. You have to upload the vertical one for your UMic, and the tip has to point towards the ceiling. For surround system measurement, that is what you have to do. If you're only gonna measure front, left, right, and center speakers and nothing else, then use this one and use your microphone in vertical position. It should be at the listening position, ideally in the middle of the speakers, very central, and at ear height. And the tip should be looking upwards, and the tip has to be at your ear height. So I upload this calibration file and close it. So don't show this message again, and turn this off. Preferences, view, maximum measurements, 500. The more the better, and you have to restart REW for that. So let's restart it. No other change needed in this tab, including the speed of sound. No matter what speed of sound your AVR uses, you don't need to change anything here. Nexus will take care of it. Sound card. You can use Java or ASIO drivers. If you use Java, make sure you use exclusive Java drivers, because as you see, there are two for my Marantz player. One is normal, one is exclusive Java, which has a lot less latency, and it can also do 7.1 floor channels. This one is only stereo. Choose this one. And as input device, choose again your UMic, but the exclusive one. You can do channel mapping here. The default is fine. For some reason, surround backs are 5 and 6 for PCs. In the Macs, they are in the right order. You don't need that because you're not going to use REW sweeps. But if you have only floor channels and if you don't want to use Atmos sweeps, then this is how you do it. I use ASIO, which doesn't exist for Mac users, I think. For example, after you adjust the input device and output device, and this is all you have to do, everything else by this default, click check levels and see if everything is working. These two are your microphones, left and right. And when you click next, you start also hearing the output. I'm hearing some bass waves now, because here I have used subwoofer test signal to check levels. I am changing it to main speaker test signal and check levels. I think you can hear this. This is my output, and I can hear my Marantz from my speakers, and UMic, which is a stereo mic, UMic 2, is also hearing it. This is good enough. When you see it like that, when you see these two don't move at all, then your mic is not working. For this one not active, then your output is not working. Sometimes you have to do this check twice until the microphone understands that something is going on, but that's all. And this is all you have to change here, really. The settings here are not important because you can also change them in measurement window. Also sweep level and everything. Everything else the same. If you're using ASIO, you have to click this one, ASIO control panel. ASIO is something you can download for, it's free. So search for ASIO for all. Something to remind that the new version 16 caused problems in my computer. I'm on 2.15 since many months, so I had to uninstall it and install back the 15th version. So just so you know, if you're gonna install ASIO for all, and if it doesn't work, just try to find version 15. The website was a little suspicious too, so I don't know, maybe I did something wrong. But anyway, this is how you download it. Back to REW. With ASIO, you have all the sound output and input channels on your PC available. You can see them here. Okay, if you don't see it here, it's not connected. This is my UMic. Okay, if I'm gonna use UMic, which is connected to a USB port on my PC, I just click this one and this one. Sorry, not this one. Let's open it. By the way, by default, it comes like that. you have to click this one to see the details. So look, instead of this, you can see them like this. On my HDMI output, I have 3 HDMI outs because my monitor is also connected with HDMI, I think. Just then you click reload and the play signs will show up next to the active ones. And if you see here 8 outputs, then this is the correct HDMI output. It is the Marantz. If I select this one, for example, and reload again, then now the play sign is here, but I have only 2 outputs. So this is definitely not the Marantz. So this is the Marantz now as output, and the input is UMIC. And I can see here, this is left channel, right channel, center channel, subwoofer, surround left, surround right, surround back left, surround back right. With ASIO, you can see the names, you have to know them. But when you check levels, you will understand which speaker is active. And input, UMIC 1 or 2, doesn't matter. We will have mono measurements. And asking for calibration file. Here, first of all, not separate calibration for left and right, just one because it's mono. And you go and upload the 90-degree calibration file for your UMIC because it's going to be pointing up towards the ceiling because you're measuring a surround system with ceiling speakers and rear speakers and what have you. But if you have a stereo system or if you have only front, left, right and center speaker and subwoofer, then use it horizontal and use this calibration file. Most microphones don't even have different calibration file for 90 degrees vertical position, but UMIC has them, so use it. So this is the calibration file. You can always go and check your calibration files here. Only the pink ones are active, so every time you change something, REW shows it up here, but this is now uploaded as a calibration file. This is some place you can always check. And it's important, without calibration file, even the best microphones can have major deviations from the actual frequency response. Sound card calibration, you almost never need that unless you have a very old and very, very bad sound card and an XLR microphone that you're using it with. So without an audio interface, this is completely useless. With a USB mic. Now this was with UMIC. Now let's see where Audyssey microphone is. It's connected to microphone input on my PC and I think it's this one. So now I have to click these two and I have to unclick UMIC and click reload. So the play sign is gone from UMIC and it's here. And let me check levels. So, okay, audio output, of course. Again, my Marantz and check levels. Sorry. Check levels. You see the movement here already, the blue light. So it means Audyssey microphone is now hearing. Even when I speak, it's moving up and down, as you see, and it's quite far away. So this is how you measure with Audyssey microphone. But of course, with Audyssey microphone, you have to go and select a different calibration file, which is gonna be provided to you in the download folder link, of course, and it's, oh, here, this one. It's the standard batch calibration file your app already uses. It's an identical version of it. It doesn't have any base correction, but will do the job at least as good as Audyssey itself because it uses the same calibration file. You still have a lot of advantages, as I explained earlier, even when you use this microphone. I will use my own audio interface microphone because next step is I'm going to show you how to center the speaker, and UMIC is not really in the middle of two speakers right now. I just connected it to show you how a USB microphone was connected. So I just take this off and select my ultralight Moto audio interface, reload, and it comes. Now my Earthworks microphone must be active. Again, input this one, check levels, nothing. Again, check levels, again nothing. There is something wrong. Let's see what can be wrong. Because I was doing pre-out measurements with that, I guess. Mic on in, everything in, home. You need phantom power for microphones with audio interface. So now I turn it on and let's see now. Again, ASIF for all. Reload, just check that the play signs are at the correct places. Everything fine, check levels. And now you see that my microphone here is hearing the signal. These are all the settings you need for perfect measurements, nothing else really. Here, unless you're gonna use loopback, which you don't need, especially with the USB mic, all these should be ticked, and they are ticked by default. So nothing you really have to do that other than unticking this one. If you are not using an audio interface, this is not really necessary at all. Everything else can stay the same. Equalizer, drop filters, if gain is small, untick that. These are all the settings in REW. Now the measurement. First, your AVR volume should be at the volume you listen to your AVR, which is, mine is now at 85 dB, minus 15. But REW is gonna send minus 12 dBFS signal, so what I'm gonna be hearing is not gonna be actual 85 dB, so I changed this to 0. Frequency range starts from 0 but goes to 24,000 because we are measuring it at 48,000 sampling rate. It should be half of that Nyquist limit, and for the calculations this is very important. It should be full range, 0 to 24,000. And here you select use acoustic timing reference. That makes sure that any microphone you use will be perfectly timing the distances between your speakers. By the way, this increases the volume by 12 dB, so be careful. Don't turn your amplifier all the way to 0 and make this 0 and check levels. You can lose your hearing, as you see. It's a lot louder now. This is how you check levels, and when output is selected as 1, this is your front left. When it is 2, check levels, this is front right. This is subwoofer. Something like that, okay. And surround left. And surround right. And I don't have surround backs, and you can't measure ceiling speakers or front wide speakers, any kind of Atmos speaker from REW like that. But all the other settings are always the same. Now, for Atmos sweeps, actually let's measure one just to see. Yeah, I was going to show you how to center the microphone. To not listen to the whole bass waves of a sine sweep and to keep it short, make this 10,000 and make this 64. The shortest possible, and it only starts from high frequencies because you need only high frequencies to measure distances. I'm just centering the microphone at the moment between left and right. So make a right measurement, timing reference, right speaker, okay, 1 and 2 here, reference output, acoustic timing reference, 64, start. From 10,000 to 24,000, most of which I didn't hear. Now, as you see, in overlays impulse graph, and because I reset my preferences, that comes as dBFS, which I hate, change it to percent. This is the impulse. This one touches 100 here, this one doesn't, so it's polarity inverted, and somewhere at minus 78 microsecond is where my left speaker peak arrives to the microphone at the moment. Now let me measure the right speaker with again the same reference output, right? Okay, now this is the right speaker, this is the left speaker. Okay, bring your mouse to the tip of the right speaker. Right speaker is the reference, by the way, so its timing is perfect, supposedly. I mean, it's not gonna change its place by the change of microphone location. No matter where you move the microphone, the reference speaker always comes up at 0. But the left speaker depends on where your microphone is located. Press Control button and right mouse click and move your mouse Like you can move anywhere as long as you hold the control key and bring it to the tip of this one here, like that. See here, you can read the distance in time and meters and in inches. So 0.039 meter, this is 3.9 centimeters. So my microphone at the moment is 3.9 centimeters closer to the left speaker than the right speaker. So I have to move it about 2 centimeters to the right. I will go do that and remeasure. Just a second. Once you're below 3 centimeters, actually you're done, because these Denon Marantz receivers have accuracy down to 3 centimeters. So 1, again, 2 will always be at the same place. I will show you soon. Remeasuring my left with only high frequencies, which we need. And so this one, compared to this one, I managed to move it only 0.6 centimeters to the correct side. So this is how you do it. You just go move your microphone a little bit, and then when they are within 3 centimeters of each other, your microphone is comfortably centered. This central position should also be where your ears are going to be. It's important. I mean, the better you get this, the more immersive your sound will be. So this is how you center your microphone. You will see that although I moved the microphone, when I measure right speaker again, this 1 second, it's going to be exactly at the same place, because it's the reference, acoustic reference speaker. It's not gonna change its location. Look, this one here and this one are still the same. I can go move the microphone a little bit more to the right, but for the sake of time, I'll leave it here. So this is how you center your microphone before you start measuring your speakers. Remove all these measurements. And measurement range normally is from 0 to 24,000, which is a lot more bass heavy. These are all the settings. Now, how do you play Atmos sweeps and measure your Atmos speakers? Instead of from REW, you go to from file, and you have to upload a reference file first, which I have provided you in the Atmos sweeps. It's a reference file that REW generates. You can generate it on your own in REW if you want. You have to upload this one just for once. This tells REW what kind of sweep it should expect. It's the same as the Atmos sweeps in format. And once you upload that, as you see here, there is a sweep file named 256K. Automatically, the length and repetitions, everything is closed, because you're now gonna measure from plate files. Check your calibration file is in place. Okay, it's no longer Audyssey mic. I need to upload my Earthworks calibration file, which is here. This is what you do in REW. Now you have to have a VLC media player installed, which is this one. And again, this is in reset settings, so I'll show you everything. You can download it from the web, it's free. And this is the, as I said, initial preferences. You go to tools, preferences, audio, and HDMI audio pass-through is disabled by default. You have to turn it to enabled, not AC3 or DTS, enabled. And output module, Windows multimedia device output. And default device, because it keeps changing, otherwise just select your Marantz or Denon. And that's it. Save. And these are all the preferences you will ever need. This is the Nexus folder you will have in the download link, and you will have them zipped, of course, but I unzipped one here, and these are your sweeps. As you see, you have the reference file that we just uploaded, and a sweep for every single speaker that is possible in Denon Marantz receivers. Okay. Now let's suppose I'm gonna measure my top front left. One thing you should do is pick up all the speakers that you have. In my case, I have front left. I click Control button and I have front right. I have top front left, top front right, and I call them not top rear, but rear height left and rear height right. It sounds better with Dolby encoding if you choose them as rear heights because they are not exactly on the ceiling, they're at the corner. And I need either LFE or SW1 because I have just one subwoofer. And two surrounds, surround left and right. They come with A, this is the convention. So I better make a playlist from them. Add to VLC Media Players playlist. That makes it a lot easier to repeat measurements and whatnot, and you can always get confused while picking them up in the folder between all these speakers. So add to media player playlist. You have a list of these here in Nexus. By the way, here, whenever you can check, this is on at all times during optimization and every other time. So when you need to name a speaker and you are confused about what its name is going to be and what position that speaker represents, here you can find them. Anytime you click this. This does have no other function, really, just to show you the reference names. So these are all my speakers and a subwoofer. Just one. Copy. Make a folder on desktop, the usual stupid style. Let's call it VLC. I mean, this is just for convenience. We should have already started measuring and paste a copy of them. And now TFL. I think audio device again changed. No. REW has that, sorry. Now this is why it's silent. ASIO has this thing that whenever something is using its lines, like REW right now is using the amplifier, nothing else can. Okay, this is how it bypasses all of Windows. So with Java exclusive drivers, you don't need to do that. It's automatic. But with ASIO, you have to click this and turn it off. And you will get the message also in REW that the player connection is lost. See, ASIO device has been. And now ASIO is free. VLC will be able to play that file, I hope. Yeah, it does. And it's coming from my top front left speaker, literally. I found the playlist actually, it's here. Okay, now here TFL, you select TFL or double click it and it starts playing TFL. And here it shows you, see, TFL MLP. Okay, for measurement, and it keeps playing them. I mean, I think there's a setting to stop that after just one time. You can find all these things. It's just a media player at the end of the day. Measure, again, this window. We have to make REW a bit smaller, really. My screen is already shrunk at the moment because it's an ultra wide and I'm recording it, so it has to be 16:9. Okay, measure, where were we? Here, we uploaded the file. From here, it's not gonna change. We only upload it once. Calibration file is in place and we click start. And nothing will happen up until REW hears the acoustic timing reference. See, it's waiting for timing reference. You can cancel it and restart it. Wait for it to capture noise floor. This is important for accuracy of the measurements. This measures the noise level at the room and ignores that part and measures only the speaker. So it's quite important. And when you click start first, it will start measuring the noise for a couple of seconds and then say that it's ready. Look, start, capturing noise floor, 50%, 100%, and now waiting for timing reference. So wait only this much, and from now on you can wait forever. It's gonna wait for the signal first. Without hearing that, it's not gonna do anything. It can stay like this for hours, and whichever speaker you want to measure on the line at that point, like TFL, double click. Look, it's playing from VLC and REW is measuring it. You can see in the graph and also this one. And when it hears, and stop that because this keeps going, but when it heard the two acoustic references at the beginning and at the end, it already captured the measurement of my top front left speaker. And name this is a right click you come here and right click. Sorry, I do these things too fast because I kind of use REW more than a lot of people, I guess. So TFL and click anywhere else, and now you have a name for it. Obviously, go to all SPL, limits, fit to data, and it comes the level it's measured. Look, it's measuring it at somewhere around 110 dB because this is an audio interface, Earthworks. I don't have an SPL meter. It's not calibrated. The SPL could be completely off. It's probably off because I'm measuring at 85 dB. Okay, but it doesn't matter for Nexus. Although it doesn't matter though, with a USB mic, you have the advantage, the UMIC mics automatically know the SPL of the measurement because it's embedded in their calibration file. During the factory reset, they adjust them to that. So it has this advantage, but it's totally useless with Nexus because Nexus doesn't care. As long as you don't change the volume of the AVR during measurements of different speakers, you're fine. My AVR will stay at -15 all along until I finish measuring all my speakers, no matter how many times I want to measure them. And go to distortion here. Again, limits, fit to data. You have to do this in every window so you can see everything. This is the noise floor, see? And this is the fundamental distortion. If you have high peaks in your noise floor during a measurement, just delete that measurement. Now, let's measure again the same speaker under the same conditions. I clicked start. There's nothing going on. I go find my VLC player and double click TFL. Anyway, go to overlays to compare different measurements and distortion. You see nothing because it's showing TV and you have to change to THD, yes. And fit to data, of course. As you see, the same speakers, this one and this one. This one has a lot higher distortion levels because of the noise in the room at the time or what have you. So I'm just gonna right click and remove and untick confirm because it comes every time. And this is my tip. And I can keep taking many other measurements of my TFL speaker until I'm satisfied with its distortion level and what have you. Normally in a silent environment and with all these acoustics, I'm talking over the measurement. Probably that was the source of the noise. Let's now assume, okay, let's take a couple of more speakers first. By the way, the acoustic reference in these sweeps is your front right speaker. Okay, so let's measure front right just to find the distance of this speaker to front right. Now, start VLC playlist and front right, double click. A lot more bass, as you see from my focal conta. It's repeating the same channel, which is very interesting, but okay, I don't have time to fix that now. So this is my FR. Make a habit of immediately naming them because you might get confused after a while. It happened to me many times. So let's see the timing between these two. Go to overlays again. Remove that and impulse. Fit the data, which is gonna compress them a lot. So this is your reference and this is your TFL. By the way, these are the speaker responses. If you right click and variable smoothing, you can have a better idea. Look, the levels are not equal also. And my contas have a lot more bass than the focal dome flux speakers, which are on the ceiling. You take a round of all of your speakers in your system this way. I don't know if I forgot to explain anything in this regard. Now, let's have the microphone position changed. Like I moved it about 10 centimeters to the right, and I will repeat all sets of measurements here in this microphone position one more round. Okay, click start. Imagine I did it, but I'm just gonna go back to TFL. Done. Now I have two TFL. This is how you turn them on and off, by the way. I don't know. You don't need to know this, and this call this TFL 2 or whatever. Okay? TFL second mid position. You will delete them anyway. So you have this one and maybe 10 others for TFL, okay? It could be at the same mic position, it could be at different mic positions, it's all up to you. And go to overlays and impulse. As you see, the second mic position is about 9 centimeters away from the first one. Doesn't matter. You have to just know which one is your central TFL measurement. Maybe even call that TFL 0, just not to get confused. If you have too many measurements, you can have up to 500. So with TFL 0 and TFL second mic position selected and no smoothing, it doesn't have importance, but just to show them. And with variable smoothing, actually, yeah, fine. Do you see the high frequency disturbances in the sound? And people are talking about filtering and equalizing this. Look, it is somewhere between here and here. About 24 dB difference at just 1 Hertz frequency difference. Look at the bass response. You can see what the response is like, so you can correct it. But starting from about 250, look what's happening. And here, any kind of filter you apply is complete nonsense. You have no idea what the real response is. Anyway, you have to average these measurements to end up at just one measurement for every speaker in your system. This is how Nexus is gonna work. Even if you had 10 other TFL measurements, what you have to do is cross-correlation align them to each other. And while doing that, you have to watch the impulse peaks in overlays graph. So I'm opening both of them on the same screen so that you can see both. The one that every other speaker will be aligned to is the central position, which should be on top of the others. Let me explain this further. For example, you can click and move them up and down in REW like this. If I cross-correlation align these two now, it's gonna be the same thing, sorry. Let me put it down. Yeah. If I cross-correlation align by right-click and choosing this one now, the two selected measurements will be aligned between each other, but this one is going to be aligned to the position of this one. Whichever one is at the top will be the one all other speakers are aligned to. If I select all three, everything will be aligned when I click this one to FR speaker, which is nonsense. To align all of the TFL measurements to TFL 0, you have to put TFL 0 to top. In fact, because you measured the central position first, most probably, they will already be on the top. Like, it shouldn't be on the top of everything. It should be on the top of other TFL measurements. Okay? So you select these two, and I will click this time cross-correlation align and watch what happens. This is the center reference measurement for TFL, and this is the other mic position. Before that, let me take a vector average of these measurements here. And deselect this for the time being to show you the difference of cross-correlation alignment. Cross-correlation align. Look what's happening here. This one moved all the way on top of each other almost perfectly, and because they are in different mic positions in the room, their impulses are different. But now they are time aligned between each other because the peaks are right on top of each other. And you have to double check that these two are on top of each other like this. So now these are aligned, and let's now take the same two measurements highlighted, vector average. Okay, vector average is going to work whichever measurements are highlighted. If you select these three, if vector average is going to be the vector average of these three. Vector average is your friend because this is the final speaker measurement you're going to feed to Nexus. Of course, I'm not going to vector average front right speaker with top front left. Now we have two vector averages. This is after alignment, and they are both TFL, post alignment, let's say. And this is the Audyssey way of averaging TFL without aligning them first. And more smoothing will show you Look what happens in the high frequency range. Again, you don't correct above 300 because you don't have the right frequency response. This is completely wrong, and this is quite right. And this is the one you have to use with Nexus. Imagine you finished all your speakers and subwoofers. With subwoofers, you can take each subwoofer measurement and name them SW1, SW2, 3, 4, what have you. And Nexus will overwrite the ADY file and align your subwoofers between each other. Make the proper ADY file for you, ready to be transferred. But the speaker names should match, as I explained before. This post alignment one actually is your real TFL. And every other, like this one, and this one, right click, remove selections. Selected ones are going to be gone because we don't need them anymore. And this, in fact, right click and rename is the TFL that I'm going to be using as my TFL response. As you see, you're very free in how many measurements you take, how many mic positions you want to measure, but just cross correlation align every speaker to the one at the central mic position measurement, and then vector average them, and then delete all the others and keep that vector average with the original name of the speaker. This is all you have to do for Nexus to work with your manual measurements. And with subwoofers, you can do the same cross correlation averaging and whatnot, but every subwoofer is a different speaker. If you have two subwoofers, SW1 and SW2 are separate. Don't cross correlation align them to each other or anything. And once you have all the speaker measurements here, of course, I'm not going to take all these measurements now, and I'm going to open one for you that I used for developing Nexus. This is very real. These are my averaged all speaker responses. By the way, I was thinking why it's so ugly, because in View I never use tick traces, but by default it is the way that way. And the colors, right click, set colors to default. Yeah. Shift fit to data. So this is my system. As you see, one subwoofer and rear height, top front left, top front right, front left, front right. I don't have a center speaker. And if you look at the notes of these measurements, of course, because it's defaulted, it doesn't show. Where was that? Show measurement notes in tooltip. Okay. Now, when you come on to that without clicking, it's a vector average of FL and FL1. I have taken two with different mic positions for this one. This is vector average of measurement. See, for subwoofer, I have taken a lot more averages, for example. But at the end, I have only one for each speaker. The order of these is not important. Your FL can be here, your subwoofer can be here, and your RHN can be here. But there should be only, I mean, Nexus will sort them out, but there should be one speaker for every speaker in your ADY file. Let's go to my ADY file, which has this. Let's see the basic one that I sent to the receiver for calibration. As you see, I have FL, FR, SLA, SRA here, TFL, TFR, RHL, and RHR. And finally, the last one is a subwoofer. Just to imagine this was a directional one, and I added another subwoofer named SW2. Let's suppose this was my original ADY file with two subwoofers, okay? And save that as two subs. And always save to desktop because I'm messy. Okay, ideally I should have done it with the right ADY file, but I'm gonna first show you the errors. Of course, why not? So this is your REW. Where is our script? Right click, reload, upload sample calibration, and let's imagine instead of that, let's first do it with the right one, right? I mean, this is the correct one with just one subwoofer. And now REW is open, so you can see that Nexus successfully. Subwoofer count, consistency checks passed, all speaker checks passed, proceeding with subwoofer checks. So it already compared everything in the Audiophile with your speaker measurements here, and everything is fine. And optimize calibration button is already highlighted, so you can use it. It's ready to start optimization. You can still create more measurement ADI files if you want at that stage. You can still look at the speaker names to compare, like what was TFR, and here you have it. And let's click optimize calibration. Here, the only difference from Evo, first, there is no force MLP because everything is MLP here, but you already averaged them. And here, because lots of people either wanted to limit low pass frequency surge range for subwoofers, and some of them wanted to unlimit. So there is now auto mode, which is Evo's mode, and Evo could cap it, but this can also force uncapping it. So even if you have one subwoofer, you may force Nexus to search up to 250 Hz low pass filter of subwoofer. This is the only difference, and force MLP is gone. Everything else works the same. And let's auto will cap it because I have only one subwoofer, but because it's in the middle of two speakers, I actually uncap it, but it's gonna take longer. So optimize, and look, it's already sorted, alphabetical order. Subwoofer is at the end, it gave them a 0 in this. Target curve not found. Orange are warnings that you have to do something about. Reds are errors. Whites do nothing about them, and blue are for the enthusiast who wants to know what's going on. But anything orange here, you have to do something about it. Anything red here, it's an error, you have to restart. So as always, I forgot to upload a target curve. We can close this waterfall glove. We don't need it. And you will have access to this folder. As always, popular target curves, and my most recent favorite, Harman Kardon. I like this one lately, but feel free to try whichever. What does it say? Yeah, this is how we uploaded it. So reload. I mean, you don't have to click reload every time. You can just here click Nexus HTML again. Upload calibration. Okay, let's this time, for example, what did we run it? Yeah, let's run a successful optimization first. Oops. Because these are different now. They have different names, see? It's giving you errors. Unmatched speakers. Because remove all and load your .dot file. My original measurements, if I reload now and upload this one, no errors, see? Optimize calibration. From here onwards, it's very similar to Evo, except for some minor changes. On this minor change is already here. Calculated average target level 85.02. New target level optimized for minimum total speaker deviation 83.70. It picks a target curve level so that no speaker is deviated too much by the 0.5 dB force. It's quite a clever algorithm, and it's useful, I think. You will hear the difference. I think about in 3-4 minutes it's gonna complete. Nothing blue around here. Speaker levels are all adjusted. These are the graphical crossovers. See, it's quite makes sense. And the final speaker distances, subwoofer, keep the polarity as is. Very healthy subwoofer distance. The crossover frequency, dip removal efficiencies increased a little bit in this version compared to Evo, but still LFE plus main almost always beats them. And here are the crossovers. All these 6 speakers are the same speakers. They are tiny satellites, by the way, for people who worry about their speakers. It's just some are very close to the wall, some are on the ceiling, some are at the corner. And here comes the optimized ADY file for by Nexus. There's a version number, there's a time of production, 2024 month 29 13 past 8. You cannot confuse two ADY files with each other easily with this one. And save and send this ADY file to your editor app and transfer it to your AVR. Do the orange things manually that the ADY file cannot do, which is here. Front speakers will be set large full range. This ADY will do, but set subwoofer mode to LFE plus main. When you send the ADY file to your AV receiver, you don't even have to go to your receiver. You can do it here. Speakers, bass, LFE plus main. And LPF for LFE, what did it give us for? 80. So this one, front speakers are already large. And crossover now is subwoofer. You have to make this 80 because bass is LFE plus main. Okay. That stays 120 Hertz because my subwoofer, as you can see from its response, it goes all the way to 250 Hertz. 120 Hertz LPF subwoofers go down like this. And Nexus, different to Evo, also I forgot to say that, calculates that. It doesn't take it from the ADY file because the ADY file you upload could be irrelevant. Audyssey usually takes them wrong. So this one calculates whether your subwoofer is 120 or 251. Will warn you accordingly and will adjust the ADY accordingly. Okay, that's why it's important you send the base ADY to your AVR first, because only then you can measure the subwoofer correctly. Otherwise, it's gonna apply filters to your subwoofer. You won't see its proper response. You're gonna measure your sub, and although this is its response, you're gonna take something like this. So again, when this is LFE, your crossover for front, and when your fronts are small, the crossover here is really the crossover of your front speakers at 80 Hertz. But when your fronts are large, which Nexus will set for you, and bass is set to LFE plus main, then this crossover here is subwoofer's LPF frequency. And you have to do that manually. So this bass LFE plus main, you do manually and go to this crossover and change this to whatever Nexus told you to do in orange warning, also manually. The only other thing you do manually here in bass is LPF for LFE, which is something different. This is either 120 or 250, okay? Most often it's 120 by default. And if your subwoofer is like mine, is producing frequencies up to, let's say this is the target level, okay? And here you will see that up to 250, it still has production. Some subwoofers, especially made for large speakers, they have a cutoff frequency at 120. So they look rather like this. This is Nexus doing some operations here, but I'm just gonna show you. Ignore what I'm doing now. I'm tricking REW into having a different subwoofer. Okay, some subwoofers are like the yellow one here, okay? They roll off much earlier at 120 Hertz. With these subwoofers, if you also select here 120 default, then this is what you will get. The receiver will apply another low pass filter at 120 Hertz for it. It's a link with Riley with 24 dB for octave, and this is what your sub is gonna sound like. Okay, so this was your sub, and because this is 120, this is what is gonna be sounding like. So you will lose some SPL around here in the audible 100 frequency and below. Very little, but still, I mean, this is the effect, about 1.5 dB. So if you have such a sub that is early cutoff, Then making this 250 has an advantage. And let me show you the advantage. This was your original sub, and instead of the 120 that receiver is applying to it, suppose it was at 250. So this original sub, set colors to default. Okay, this was your original sub, and with the LPF 120 here, this is what you hear from LFE channel, okay, the special .1 channel. This was what you're gonna hear, not your subwoofer in general. Your subwoofer is filtered wherever it's crossed over to a speaker for each speaker. But by changing that to 250, you managed to do it like that. Remove that. So your LFE channel improved from this one to this one. If you go psychoacoustic smoothing, you will see that it has a minimal effect of about 2 dB in a very audible 80 Hertz. So it's useful. Okay, it's not a must that you should do, but it's very, very useful. And Evo will warn you to do that. And it's independent from what you change here in crossover, which is base extraction frequency in the new models. In the old models, this is how you do it. That base should be LFE plus main. In my case, it's going to be 120. Because my subwoofer is 250, this should be 120. If your subwoofer is 120, this should be 250. So the opposite here. The less you filter, the better, because subwoofer is already filtering itself. I forgot to mention some other adjustments before measurement, I guess. I am just checking my notes finally. You have to turn off loudness management in your receiver. It's here under surround parameter, under audio, okay? But you normally see nothing here. Only when an Atmos signal is played, you will see that menu. So I have to go now and play an Atmos signal. Okay, any Atmos signal, even front left channel will do, because it's, again, that's also Atmos. Look, if I refresh now, go to surround parameter, see, I see these settings, and loudness management is off, dynamic compression is off. This is very important, cinema EQ is off. It will only be coming up with an Atmos signal, and the moment I stop this, it will go away. And if you try to change it after you stop it, it's not gonna be affecting it. Look, let's see, on, and when I refresh it, surround parameter, oh, it's gone again. So let's play that again and check again, surround parameter. See, it's off, so I couldn't change it because it was too late. Atmos signal should be playing. This is one very important setting because it's gonna dim down the volumes. Also in your movies, very important, turn this off and you will thank me later. What else from my notes? Echo mode off during measurements, definitely, okay? It does very weird things at different volumes. You can afterwards take it to auto, which will apply echo mode up to 30 dB, minus 30 dB, and from then on it will switch to on, so it's okay. But there will be something, a relay switch you will hear at 30 dB every time. If it's at on during measurements, you will not be measuring your speakers, okay? You will only be measuring a lot of distortion. Keep it completely off for measurements, and then when you're using the AVR, keep it at auto, never on. What else is left? Okay, now let's run Nexus with some problems. Open my measurements again. So let's say I have two subwoofers, but I will fake it, of course, because I don't have. Just response copy and name this SW2. And to change its response a little bit, let's apply some filters to it. This is gonna properly change. So remove this one, and this is my new subwoofer too. Let's say I have a subwoofer, something like that, and go to SPL and phase graph, select that, and offset T equals 0. And it's also obviously not at the exact same location, but it is moved by, no, this is not enough, this is better. It's about 2.4 meters in a different place. How do I know? I mean, I'm manipulating now, so don't do any of these things, but you will see that now two subwoofers are quite different. Their peaks have a difference of 2.1, 2.4 meters. Suppose these are your measurements. Okay, you measure two, and I still have the same ADY file which has only one subwoofer in it. Let's upload it to Nexus. There's another way to run Nexus, which is here, much easier. Okay. Upload sample calibration, Audyssey measurements. Okay, look what happened. Mismatch in the number of subwoofers between REW. In REW there are two, and the uploaded ADY file, which is one. Overriding calibration file subwoofer structure based on the number of subwoofer measurements in REW. So it says in REW you have two subs, but in the ADY you have one, and I'm gonna be overriding it. Now it already did that. Subwoofer reconciliation complete. Consider saving a copy of the updated base calibration file for future use. Let's do that. And save it. And let's check in JSON what it said. As you see, it has now two subwoofers. You can send this to your receiver and it will be all set with custom levels, delays, all zero, and no response because it's standard sub, but this one has response and they're perfect impulses. So this is how it works. And obviously, when you start optimization, it's going to align two subwoofers between each other. Always keep REW in SPLM phase tab. Look, this also works, but it slows everything a lot down and can cause errors at times when you have too many speakers. So this is important. There's also a reminder here. Look, aligning multiple subs between each other for best bass performance. It's gonna time align them and then use them as one sub after a certain point and do all the adjustments. The center speaker distance, we can check that. In the new Nexus, we have here the custom crossover search range is still here. You can define here your crossovers. If you don't like what Nexus is coming up with, you can change the search range. You can only even write just one frequency and it will end up in that frequency, which I don't suggest. But I also added this, another unnecessary variable here for center speaker distance, because when there is no center speaker distance in your ADY file, which happens when Audyssey cannot find the distance for your subwoofer, just decides to delete them all. Only when you edit in your app, they come back. Nobody uses this distance for time delays, including the amplifier itself, okay? It's just eye candy, but some people are bothered about this. So if you're desperate about it, when you enter your exact distance here, the meters, then Evo will use that one for your center speaker. In the lack of center speaker, it will use front left, like the case in mine. If you don't do anything and there is no center distance value, it will use 2.75 meters. Could just as well use 5 meters. Doesn't make any difference. That's another addition. And shall we wait for this to finish? Ah, okay. Now imagine, let's not wait. I still have the same measurements and I run Nexus and upload a calibration totally irrelevant, which I have a lot, like Maran's 8, some guy's ADY file. Look what it says. Unmatched speakers were found. In REW, RHL, RHR is talking about these two speakers of mine. Here you can see better. In the uploaded calibration file, there is C center speaker, which I don't have, and there is TRL and TRR. Measurements in REW did not match with the speakers in the uploaded calibration file, unable to detect REW measurement. This is the case where it warns you and you really have to do something about it. Whatever you did wrong, maybe you misspelled them here, or maybe you uploaded a different ADY file with a different amp assign. So you have to fix that and rerun everything, like reload. Let's this time upload the correct one. This one will work. Optimize calibration. And it started optimizing. Go to SPLM face up and pause. Look. Because it's doing the excess phase calculation between speakers, optimization is paused. So now you can come here, do checks and what have you, you can save this part, like these original measurements, everything aligned. You can save this. They're also sorted, or take copies or calculate some things. I don't know. And the moment you press back to SPL and phase, resume, it's going to continue. You can pause again until it finishes the filters. For example, it says optimization will be paused at the end of the current process. So it will have to finish all the filtering and then we'll pause. But in every single full step, you can pause it. Look, optimization is paused. So because the filters are not finished. For example, if you open REW now, you have the first range of filters. There will be another set of filters. Somebody asked if they can manipulate at this stage. Yes, you can, but I strongly suggest against it. And resume. So this is one more. I don't know if I should do this in video in 2 parts because it's gonna be like 2 hours and no one will watch it. I mean, I would never watch any tutorial if it's 2 hours long. I never have 2 hours at a time to watch something. Let's stop this. Now in the download folder, you will also find something called no DEQ boost.zip, and open it and double click it. It works only on Windows for now because it's an exe file. You have to run it anyway. But look what it does. It's because of REW, I think. ASIO problem. Yeah, it's worked now. It's reading the AVR volume level every 2.5 seconds and checking when you change the volume of the AVR and how can I change it from here. This web interface cannot do just one thing. It's changing the volume. There are ways to send the code and change it from here, but I can use the remote app on the phone. Look, it is checking and there is no volume change. Everything is fine. Now I'm going to change the volume from -30 to -20. And I did. Look what happened. It changed SL, SR, SP, FHL, FHR by this much dB because the relative volume changed. So it detects every time you change your volume and adjusts extra surround and height boosts accordingly. So dynamic EQ keeps consistent levels at all times. It's a work in progress because we didn't really measure the dB levels here very accurately yet. I didn't have time, to be honest, but it will be in the folder and it works as it is. With feedback, it's gonna be perfect in time. The only problem is that you have to run this in parallel when you're watching a movie. The Mac and other versions are being developed as we speak by people who understand from Macs. I'm not one of them. I think that's it. Thanks for all your support again and see you soon.